Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve question 41 to 50 of NAT section, that is numerical answer type. Okay, these are the questions. So the first question is, for the following compound, the number of signals expected in 1H NMR spectrum is. So the first thing that you can notice is here there is a mirror plane that you can see here. Okay. So this methyl will give one signal, and on the other side of the mirror plane both these are equivalent, so they will give one signal. Okay, plus okay, these hydrogens will give another signal. Okay, HB, and this is, let's say, HC. Okay, but you can see that I can also draw another plane like this. So this B and C are also equivalent. The total how many signals we will see? Total of only 2 signals we will see. So the answer is 2. Second one, exhaustive hydrogenation of the following compound under palladium charcoal generates a saturated hydrocarbon as the product. So what we have to do? We have to do complete hydrogenation. So we know alkynes, okay, R dash, when you do hydrogenation, a complete hydrogenation, what will happen? Alkyne will get reduced to alkene first. Alkene will be further reduced to alkanes. Okay, so the final product of reduction is alkanes for alkynes as well as for alkenes. Okay, for alkenes also the final product is what? It is alkane. Okay, saturated compound alkane. So what will happen? You just count the number of carbons that will be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 carbon chain. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then fourth position there is a methyl group. Okay, fifth position there is nothing. Sixth position again there is a methyl group. So this is the hydrogenated product. Okay, reduce all the double and triple bond, 2 double bond and 1 triple bond. Now here if you see, this is one chiral center, this is another chiral center. So if you write down the formula for number of stereoisomers, it is 2 raised to n. N is the number of chiral centers, so it will be 2 raised to 2, that is 4. But is the answer 4? No. What will happen is, this is what? This is a meso compound. You can see there are 2 chiral center plus there is a mirror plane. Okay, so one of the isomer, that is a meso compound, will be what? It will be optically inactive. A meso compound will be optically inactive. Okay, so that will not be counted as a optically active isomer. So 4 minus 1, that will be 3. So total stereoisomers possible will be 3. So the correct answer will be 3. Okay. Now let us move on to the third question. For a zero order reaction, 43rd, zero order reaction, very important. Write down the order of the reaction. P becomes P to Q. P is the reactant, Q is the product. Concentration of P becomes half of its initial concentration in 30 minutes. So what is given is T half. T half is 30 minutes. Okay. What is T half? The time taken for reactant concentration to become half. Okay, the concentration of P becomes 0 at what time? So when the reactant concentration, that is 80, after time t it becomes 0, at what time it will become 0? So let us first write down the formula. Okay, AT is equal to A0 minus KT. What is AT? Concentration of reactant after time t. A0 is initial concentration, K is rate constant, T is time. First thing what is given to us is half-life. Okay, so what is the formula for half-life for a zero order reaction? A0 by 2K. What is given? T half, that is 30 minutes. Okay, so that will be A0 by 2K. So I can write A0 by K, that is 30, K cross multiply 30 into 2, 60. Okay, so this is the equation that will be useful. Now we can substitute AT, they have given it is 0. Okay, A0 minus KT. Okay, what will be the time? A0 is equal to KT. We want to calculate the formula of time. Value of T. T will be A0 by K. Okay, A0 by K we calculated just now. It is what? 60. Round off to the nearest integer. Very important to read the instruction of the bracket. Nearest integer means no decimal points. Okay, you will write only 60. Okay, so this is the final answer. Next question, the magnitude of energy difference between energy levels n is equal to 3 and n is equal to 2 of a quantum particle of mass m in box of length L is. Okay, so what is the energy? Formula for energy for a particle in a box is equal to n square h square by 8 ml square. What is n? N is the energy level, h is the Planck's constant, m is the mass, L is the length of the box. Okay, m is mass of the particle. Now what they are telling us, to find out the energy difference between two energy levels, one is E3 minus E2, n is equal to 3 and n is equal to 2. So substitute n is equal to 3 in this formula of energy, it will be 3 square. Okay, so that will be 9h square by 8 ml square minus E2, n is equal to 2, so 2 square will be 4h square by 8 ml square. Okay, now h square by 8 ml square is common, so I can take it outside. 9 minus 4, 9 minus 4 is what? 5. So 5h square by 8 ml square, it is given, that is xh square by 8 ml square. So compare both the equation. What will be the value of x? X is what? X is 5. And again round off to nearest integer, so you will write just the number, that is 5. Okay, now let us see the next one. The function exponential minus 2 into x minus 1 the whole square attains a maximum at x is equal to. So to find out the maximum, what are the two steps that you have to follow? First, you have to derivate. Okay, derivate that particular function, whatever is given, and then equate it to 0. That is what we are going to do in this question. So what is the f of x that is given? Function that is given, it is exponential. I can write e raised to minus 2 into x minus 1 the whole square. This is the function. We have to differentiate it. Okay, so differentiating this with respect to x, and then we have to equate it to 0. What is the derivative of e raised to x? It is same as e raised to x, but here it is e raised to ax. Okay, so it will be e raised to ax into derivative of the exponential part as well, ax. So same thing that we are going to do here. Okay, so derivative of e raised to minus 2 x minus 1 the whole square. Okay, we have to derivate this and equate it to 0. So what is derivative of e raised to x? It is same, e raised to minus 2 x minus 1 the whole square into multiplied by derivative of this raised function, that will be minus 2 into x minus 1 the whole square is equal to 0. Okay, this entire exponential term I can bring it to the right hand side, that will become 0, divided by that it will be 0. So just we have to derivate this bracket term. Okay, a minus b the whole square, that will be, okay, derivative of a square, this is a, this is b, a square, that will be x square minus 2ab. So 2 into x into 1, that is 2x plus b square, that will be 1. What is a minus b the whole square? It is a square minus 2ab plus b square. Here a is what? X. B is what? B is 1. Okay, so this equal to 0. So open the brackets, minus 2 minus 2 is a constant, so I can take it outside. X square derivative will be, okay, x raised to n derivative is what? N into x raised to n minus 1. So x square will be 2 into x raised to 2 minus 1, that is x, minus 2 is constant. Derivative of x with respect to x is 1 and 1 is a constant, so answer will be 0. Okay, so solve this. Minus 2, I can bring it on the other side, it will become 0. So it will be 2x is equal to, minus 2 will go on the right hand side, 2 into 1 is 2, minus 2 will go on the right hand side, it will become 2. So x will be 2 divided by 2, that is 1. So what is the final answer? X is equal to 1. Round off to nearest integer. So again you will write the answer as 1. Okay, so it is very simple what we did. We differentiated e raised to x and equated it to 0. Okay, this exponential term was in multiplication, so this we brought it to the other side, it became 0. Okay, then this minus 2 is also a constant. Okay, so that will also become 0. And 2x is equal to 2. X is 2 divided by 2. Okay, x is 2 divided by 2, that is 1. Okay, 46. This is based on which concept? Henderson-Hasselbalch equation. What is the formula for that? pH is equal to pKa plus log to the base 10 of salt divided by acid. So can we use this formula for this? Yes, but it is already given that it is a monobasic acid and what we have to find out is a pKa. Okay, we don't know the concentration of salt, so we'll go by the equation method. Okay, monobasic means it can donate one H plus ion, so we'll write Ha. Okay, this Ha can donate only one H plus ion. For example, HCl can donate one H plus ion. Basicity means the number of H plus ions that can be donated. Okay, HCl is monobasic, H2SO4 is dibasic, H3PO4 is tribasic. Okay, so Ha in equilibrium, it is in equilibrium with its ions H plus and A minus. So at T is equal to 0, what is the concentration? 0.1 molar. This is 0, this is 0. At equilibrium, this will become 0.1. Some amount is reactive. Okay, H plus is X, A minus is also X. Okay, and what else is given to us? pH is given, pH is 2. What is the formula for pH? Minus log to the base 10 of H plus ion is equal to 2. What will be the formula for H plus? H plus will be, okay, this minus will go on the right hand side, it will become minus 2 and 10 raised to minus 2. So H plus will be 10 raised to minus 2. Okay, H plus is 10 raised to minus 2. That is nothing but the value of X. Okay, so now we can substitute. What is Ka? Ka is concentration of product divided by concentration of reactant. Product is H plus and A minus. So H plus into A minus divided by HA. H plus is X, A minus is X, HA is 0.1 minus X. Now the value of X is very small, so 0.1 minus X I can write it as 0.1. So this will be X square by 0.1. So what is X? X is 10 raised to minus 2. So 10 raised to minus 2 the whole square divided by 0.1. Okay, so I will solve here. Okay, solve further. What is the value of Ka? Ka will be 10 raised to minus 2 square will be 10 raised to minus 4 and 0.1 is 10 raised to minus 1. This will go to the numerator. It will become 10 raised to plus 1. So minus 4 plus 1 is 10 raised to minus 3. Do we want Ka? No. What we want is a pKa. pKa will be minus log to the base 10 of Ka. Ka is 10 raised to minus 3. Okay, this minus 3 I can bring at the front. This will become minus into minus 3. That will be 3.0. Okay, round off to 1 decimal place. Which log rule I have used here? Log of A raised to m. This power we bring down. m log A. Okay, minus 3 log of A here is 10 and m is minus 3. So minus 3 I have brought down, minus sign was already there, minus into minus 3 will be plus 3. So the answer will be 3.0. Very important, you have to round off to one decimal place, so you have to write down after decimal one digit. Okay, now let us see question 47. Now what is the required equation that is given? Required equation is carbon gas plus half O2 gas gives CO gas. Okay, what is the first equation that is given? The first equation is given, this one, carbon gas plus oxygen gas gives CO2 gas. Okay, and delta H, let's say this is delta H1, it is given minus 393.5 kilojoule per mole. What is the second one that is given? Second equation is this one, CO2 gas gives CO gas plus half O2 gas. Okay, delta H2, this is what it is given, 283.0 kilojoule per mole. Okay, so if you see the required equation, carbon gas, it is already in the reactant side, carbon monoxide gas, that is also present in the product side. So what we can do is simply add both of them. Okay, simply add both of them, we'll get the desired equation. So add 1 and 2. Okay, if you add 1 and 2, you can see CO2 gas on the reactant and product side, it is common, so we can cancel that. Here there is half O2, here there is 1 O2. So this also we can cancel, and here only half O2 will be remaining. So what we are left with, carbon gas plus half O2 gas, and on the product side now we are left with only carbon monoxide gas. So what will be the delta H of the reaction? Just add both of them. Delta H1 plus delta H2, that will be minus 393.5 plus 283.0. Okay, the final answer should be up to one decimal place. So what is the final answer? Solve this, it comes out to be minus 110.5. Okay, so minus 110.5 is the final answer. Okay, if you see the range they have given is 110.0 to minus 110 minus 111.0. So very important, you don't have to forget this negative sign. Many times we forget this negative sign and lose the credit. So very important, you have to check whether negative sign is there in the answer or not, and up to how many decimal place we have to round off. Okay, unit also very important, it is kilojoule per mole. Okay, next one, 48, the bond order of NO minus is, so first what we will do, we'll count the total electrons. NO minus, nitrogen it is 7, plus oxygen valence total electrons is 8. Okay, atomic number is 8. So nitrogen is 7, plus negative charge means one more electron, so total there are 16 electrons that we have to fill. Okay, so draw the molecular orbital diagram. Now oxygen is more electronegative as compared to nitrogen. So the atomic orbitals of oxygen will be slightly lower in energy. Okay, so let us draw 1s. Nitrogen is on the left, oxygen on the right. So oxygen will be slightly lower. Okay, similarly 2s and then 2p. Okay, now atomic orbitals combine to give one bonding, anti-bonding. Similarly 2s will also combine to give one bonding, one anti-bonding. Similarly 2p orbitals will also combine to give bonding and anti-bonding. This is sigma 1s, this is sigma star 1s anti-bonding, sigma 2s, sigma star 2s anti-bonding. This is pi 2pz, sorry, this is sigma 2pz. This will be pi 2px is equal to pi 2p y. This will be pi star 2px is equal to pi star 2py. These are anti-bonding. And this will be sigma star 2pz. Now total how many electrons we have to fill? 16 electrons. Okay, so let us start filling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First fill singly. Okay, then 13, 14, 15 and 16. Okay, now let us find out the bond order. Bond order is half into number of electrons in the bonding molecular orbital minus number of electrons in the bonding molecular orbitals minus number of electron in the anti-bonding molecular orbital. That will be half into bonding molecular orbitals. How many electrons are there? 2, 4, 4 plus 6, 10. 10 minus how many anti-bonding molecular orbitals? Anti-bonding electrons 2, 2, 4 plus 2, 6. 6, 10 minus 6, 4. 4 divided by 2, 2. So the bond order is what? 2. Okay, 49. 49, what we have to do is, what is given, let us first write down. Bond length of carbon monoxide is 113. So L is given 113 picometer. Okay, but you can see here Debye unit is given in meter, coulomb meter. So we'll convert picometer to meter. 113 into 10 raised to 1 picometer is 10 raised to minus 12 meter. 1 picometer is 10 raised to minus 12 meter. Next, what is given? Dipole moment mu is given 0.1 dBi. Now this dBi also will convert it into coulomb meter. So that will be 0.1 into 1 dBi is 3.336 into 10 raised to minus 30 coulomb meter. Okay, so that will be how much? 0.1 is 10 raised to minus 1. So this will become 3.336 into 10 raised to minus 31 coulomb meter. Okay, mu is given, L is given. What we have to calculate is the charge. Okay, in the absolute units. So that will be, that is charge. It should be no units in the final answer. Okay, absolute charge, like we say minus 1 plus 1, like that. So before that, now let us try to understand what will be the charge on the carbon. Okay, this is a Lewis structure of carbon monoxide. Carbon has how many valence electrons? 4. So here there are how many electrons? 2, 3, 4, 5. 5 electrons. Valence electrons are 4. Here there are 5. That is 1 electron is extra. So this will get a formal charge of minus 1. That is minus. Now oxygen, if you check, oxygen there are how many valence electrons? Oxygen there are 6 valence electrons. So here there are how many electrons? 2, 3, 4 and 5. That is 5 is 1 less than 6. So it will get a positive charge. So very important, we have to find out the charge on the carbon. Carbon, you can see it is having a negative charge. So the final answer should have a minus sign. Okay, so now we can straight away use the formula. What is the formula for dipole moment? It is charge into bond length. What we have to calculate? Q. Q will be mu divided by L. What is the value of mu? We calculated just now. It is 3.336 into 10 raised to minus 31 coulomb meter. Divided by bond length is how much? 113 picometer. So 113 into 10 raised to minus 12 meter. Now if you see the final units, it will be in the unit will be coulomb. But we want that the charge, we know it has got no units. So what we do? We divide it by the charge of one single electron. That is what? That is why they have given the value of charge of one electron 1.602 into 10 raised to minus 19 coulomb. Okay, why I have divided this? Now if you see the units, coulomb gets cancelled, meter also gets cancelled. So now it is unitless. Now if you solve this entire thing, what is the final answer that comes out is minus 0.018. Okay, this is going to be the final answer. minus 0.018. Okay, so very important to add this negative sign. If you don't add this negative sign, and up to 3 decimal places, that is after point, you can see I have added 3 digits 0, 1 and 8. So very important to add the negative sign and the decimal places. Okay, and last question, the magnetic moment of O3 molecule is. So for this what we have to do is we have to draw the Lewis diagram for O3. Okay, magnetic moment formula is mu is equal to root of n into n plus 2. Unit is Bohr magneton. N is the number of unpaired electron. Now if you draw the structure of ozone, okay, the Lewis structure of ozone, it looks something like this: 1, 2, 3, 4, 5 and 6. So this oxygen has 6 valence electron, and around oxygen also there are 6, so no charge. Here there is one lone pair. Okay, 1, 2, 3, 4, 1, 2, 3, 4 and 5 electron, that is one less than the valence electron, so it will have a positive charge. And there is another oxygen which has 3 lone pairs. Now here if you count the electrons around the oxygen, there are how many electrons? 2, 4, 6 and 1, 7, that is one more than the valence electron. So it will have a minus charge. The overall charge, if you see, it is what? Plus 1 minus 1 get cancelled, it is 0. Now here if you see carefully, can you see any unpaired electrons? Paired. Okay. Total there are 1, 2, 3, 6 lone pairs, all are paired. This is also paired, single bond and double bond. So you can see there are no unpaired electrons. There are no unpaired electrons. So n is equal to 0. So substitute mu is equal to root of 0 into 0 plus 2. That will be 0. No unpaired electrons, so magnetic moment will also be 0. So the answer will be 0. Okay, so this was the last question of questions 41 to 50. Next video we will see the last 10 questions. I hope you have understood all the solutions. Thank you.